Hello. I'm just getting back from vacation, so I'm trying to get all back into this. That's why I'm kind of late. Had to eat lunch and all that. What are we up to today? Yeah, so today my plan was to just work on writing the scripts for some YouTube videos about all that I've been doing here on the stream. Kind of super boring, but that's okay. Let's see, how do I... There we go. This was broken before. There we go. Sorry, I'm getting my ducks in a row here. Ooh. Can I... I'm trying to get my calendars synced up here. Let's see. There is an export, but it exports everything. Screw it. We'll do it all. Okay. So then I don't actually want you to see this. So I guess I'll finish this later. Note to self, finish calendar sync on an Emacs. Yeah. I got these... I've had these Diet Cokes for a while. I've just been very slow about consuming them. I think I need to get me some, like, Dr. Peppers or something. Okay. Anyway, let's get started. So, I had some stuff here. Let's see. Where am I saving this? I have a sync thing. Which is it currently running? I don't remember what port it is. Sync thing, local port. 8384. There it is. Okay. Oops. Okay, it's running. It's working. Let me make sure my phone also has it on. Cool. And then I've turned it off on my laptop. That's streaming, so hopefully it doesn't kill the bitrate or anything like that. But okay, so somewhere in org, I'm gonna have a YouTube scripts file. YouTube video scripts. And basically, I want to go through and summarize everything that I've done. With hopefully this doesn't start auto-playing. I went to the wrong thing here. Channel. No, not my channel. Stream creator dashboard. That's what I want. Stream manager. All right. Okay. So, first thing I need is some kind of introduction, obviously, and I'll have some kind of conclusion question mark. But then there's a bunch of stuff that... So, in introduction, goal is to explain the project and all of its components. And actually, let me make sure. So there's a fly mode here, but it's not highlighting. So does that mean that if I spell components incorrectly, explain the project and all of its components, sure, okay, yeah, so spell check is on, cool. Explain the project and all of its components, how they fit together at a high level. And I'll call this goal. Okay, and then I don't know what order I want to present it in. I think I want to say, like, maybe I'll do some of the embedded stuff first because I find that to be a little more fun than the web part. So first is we'll do a Blinky. I'm thinking Blinky. I don't know if that's a good title. We'll think about titles later. We'll do this. To-dos. Tasks. We'll call it tasks. To do. Titles. Video titles? Yeah. Okay. So first video, introduction. It's a compost monitor. I'll write that down. A compost monitor. It reminds me of the... I always think... Whenever I say, like, write that down, I always think of the Disney Alice in Wonderland movie. Where, like, the dormouse in the little teapot says, like, twinkle, twinkle, and then... The Queen of Hearts is like, write that down. That's very important. It's a compost monitor. There's a piece of hardware that lives in the bin. There's a network appliance that listens or that stores the collected data, and that's about it. That's all the components. I can get into break down the hardware involved, and then break down the network appliance functionality / tech stack. Okay, and then we'll have a Blinky. So Blinky is really just getting set up with the ESP32S3 dev kit, development kit. I want to try to avoid, I'm thinking of it now, try to avoid abbreviations here. So I'll call it a development kit. A dev kit. Development kit, dev kit. Just as a reminder of that. So getting it set up with the toolchain Do I want to test this on... Test on Mac OS and Windows? Or just trust that people will use Linux? GNU Linux. I don't know. And I think it is called macOS now. We should probably drive people to do both, or to use whichever one they have. So, because these are newcomers generally. Like if anyone cares, they'll be kind of newcomers to to embedded development. Not necessarily software development in general, but perhaps. I imagine most people are going to come from like a web dev background. So they probably are used to like VS Code and possibly like running Node. I don't know. Or just having plugins that do it all for them. I'm not going to do that. So yeah, let me do that. Test on Mac OS. I know how to do that on Mac OS. Test on Windows. Or Blinky. So getting set up with the ESP32 S3 development kit. Maybe this will have to be separate videos, and I'll refer people to those to get set up, like on a different track, based on what their operating system is. So, set up on Linux, GNU Linux. Set up on Mac OS, and set up on Windows. I'm gonna say. I don't have Windows 11, and I don't want to have Windows 11. I do have a Windows 10 machine, which is already bad enough. Yeah, I mean, I guess, yeah. Maybe I'll Maybe I'll get someone who has Windows to test it for me on Windows 11. I'll do it on Windows 10. I think it should translate almost identically. I don't see why it wouldn't. But in case it doesn't, I'll have someone test it for me. Someone who has Windows 11. In the meantime, I might have a Windows 11 machine available to me. Like my wife's computer, specifically. But, anyway. So we'll do that. Yeah, and I might defer to these videos from, like, the main Blinky video. It's like, okay, so first you need to get set up. Or, like... And then point to getting set up videos. Refer to getting set up pre-Blinky videos as like, I'm thinking of this almost like a video course, which I don't know if that's the best way to do it, but it's my first time. So if it's bad, it'll be bad. That's fine. Okay. Blinky. So Blinky, get it set up. Oh, maybe I'll do this. Pre-blinky videos. Setting up. Environment. Setup. Setup is one word. Pre-blinky videos. Environment setup. So this. And then also for later. For later, Phoenix setup. Should be getting set up with ESP. Okay. So the plan is to have 3 videos. GNU Linux, Mac OS, and Windows. On GNU Linux, Mac OS, Windows. Getting set up with ESP32 dev kit, as well as Elixir and Phoenix kit, not kick. Okay. So we're gonna have 3 different videos for getting set up, but they're all gonna be basically the same video, just in a different environment. That's fine. So the goal here is goal content. Okay. Then Blinky, goal. Goal, you have written code. Goal, write code that executes and demonstrates real world effects. So we're blinking an LED, i.e. blinking an LED. So content first, breadboard. Okay. We also need a what you need. Also obtain required hardware. Demonstrate. Yeah. Break down the hardware involved, but then specifically point out required hardware components, i.e. breadboard, LED, resistors, what else? ESP32. Regulator for the battery. Voltage regulator for the battery. What else is on this thing? Don't forget jumper wires. And power supply? We might have a separate power supply one, but for everything up until you're actually running off a battery, you don't even need these two. Optional. For running on battery. Optional for testing without eating battery. Yeah, if you're just building it to build it and have it, it's like an actual thing, then you'll need some of this stuff. But if you're just building it for fun to build it, then you don't need it running off a battery. But I guess we'll say it's optional if you want to actually run it independently. Yeah. Elixir and Phoenix. So, okay, breadboard, the LED circuit. Well, we'll show the design process for the LED circuit. Build circuit on breadboard. What else? Test with power supply. So that might be an alteration I make then to the circuit, because it's good. It's good. I think the way I have it now, it would be difficult to demonstrate without the code, if that makes sense. So like, right now, because the GPIO pin syncs the current, there's no easy way for you to just like test how it works before plugging it into the IO pin, if that makes sense. Or I guess it kind of works like if it's unplugged and then you plug it to ground. Essentially, that's what we're doing. Or it's set to, high, 3 volts or 3 volts or 1.8. I think it's 3 volts. Yeah, so I can toggle, on the breadboard. I can just pretend like you've got it set up. You've got your little, I don't have it here, but you've got your little LED circuit, and you connect one end of the LED circuit. Normally, it's high, right? GPIO pin high, and then GPIO pin low. And then you can see the effects of, you plug in from the power rail through the resistor, through the LED, and then it starts high or disconnected, in which case current does not flow. But then you connect it to ground or high, and then that changes whether or not current flows. And then we can transfer that into code. Yeah, I think that's fine. Okay, so test with just 3v3 rail. Good segue. Segue spelled like this. Good seg. How do you define segu? Whatever this is, segue. Yeah, segue. How do you spell the segue of the little personal mobility device? What is it called? Personal mobility. Segway. I think that's a W-A-Y, right? Personal transport. Yeah, Segway. That's what I was thinking of. This thing. That's not a Segway. That's just a scooter. Where's the one I'm thinking of? Did they like discontinue it? Self-balancing. This is what I'm thinking of. This is what I think of when I think of a Segway. Not like a literal motorcycle. Man, these had a moment and then they like disappeared. I haven't seen one in a long time. Well, I saw the hoverboards fad one winter, but okay, good segue. Notation for good segue, or maybe not a segue, but like mention notation. For fractional values, i.e. 3v3 is really 3.3 volts. I imagine the reason for this is that it's harder to print dots, or that like if you print a dot, it might get lost, or is it just for compactness sake, where like you can fit, you know, 3 characters instead of 4? I don't know if it's universal, but it's relatively common. And I was never taught it explicitly, so I don't know. I don't know exactly where it comes from or what its history is or anything like that at all. Okay. So we have that. Now we write some code. Write the Blinky code. And then 5. Encourage people to play around. What are some ways to encourage people to play around? So, if you've got a blinking LED, we could say make it blink fast. Make it blink fast. Make it blink slow. Make it be on for a different amount of time than it is off. Or I'll make a quick blink but long, quick on but long off. Let's say that. So it would be like I'll do that. That doesn't look good here, but like that. Except I don't want this syntax stuff. Get rid of this. There we go. So it's off, and it's on for a very short time, and then off again. So I give myself a little diagram for that. Bonus. Show. Let's see. We'll do answers to challenges. Answers to challenges. Code for Blinky. Code for fast blink. Code for slow blink. Code for quick on, long off. Quick on, long off. Okay. So intro video. We got a pre-Blinky video. Blinky. So we're blinking an LED. We're loading code. All that kind of stuff. Write the Blinky code. We'll do 5 here. Load and run. Okay, I think that's good. So we're blinking. And then we'll integrate. What's a good first component to integrate? Maybe first we'll do analog input. Integrate analog input. This is the goal of this one is to integrate the capacitive, soil, capacitive. How does it think it should be spelled? Save the word. Capacitive. Define capacitive. Look up in the dictionary. Capacit. Yeah, that's spelled right. All right, so that's saved now. Integrate the capacitive soil moisture sensor via analog to digital. Digital. Via analog to digital converter. ADC. And content. So first, we'll do ESP32 documentation for ADC input. So we'll do an overview of that. And the associated plan. Overview of documentation for ADC inputs, plan, implementation given the documentation. Yeah, given the documentation, and then begin, so implement. So this includes the design of the voltage divider. Okay. Design voltage divider. So we'll have to explain voltage divider. And then design voltage divider. So we'll need to explain that. So, and then once that's done, component selection. Build on breadboard. Oops. And then maybe build on breadboard, demonstrate with oscilloscope. I think that's good. We can show it working with the oscilloscope. Oops. I think that's it. Demonstrate with the oscilloscope, and then yeah, five would be write code, test in code, demonstrate with code. Which I think we didn't really do this. Write the blinky code, load and run. Okay, write the code, demonstrate with code. Load and run is the same as demonstrate running code. Yeah? Okay. Overview of documentation for... Okay, and this is the part where we explain what an analog... Explain analog versus digital signals. And that explain is doing a lot of heavy lifting, but we'll get to that. So these are not yet scripts. These are outlines. We'll get there. We'll get the script eventually. But I think for the most part, this is enough for me to be able to do like an off-the-cuff thing, kind of like what I do for streams. Except the streams are much more exploratory on my part. Like, I don't know the answers to a lot of these questions coming into it. So, for example, Blinky code, I came in thinking that ESP32 board had an LED on it, which it does. And it was an RGB LED, which it is, and that I could therefore write code to manipulate it, which I could, but also is a completely different kind of LED than I thought it was. It was actually a NeoPixel, not just an RGB LED. So, really annoying. But anyway. Yes, now I actually have a reference at least for what I did. I don't remember it all in fine detail, like function names and things like that, but we got enough. All right, what else we got? So we've done Blinky. We've integrated the analog input. We also need to integrate the temperature probe. Integrate I2C probe. And then for funsies, integrate sharp display. For fun, integrate I2C display. And then we can do integrate battery, circuitry, and then refine for fun. And then I think I forgot optional here. Optional for fun. Sharp style display. LCD. Okay, integrate the analog input, integrate the I2C probe. For fun, the display, optional, integrate battery circuitry, but then we also need to integrate actually start doing web, so Wi-Fi. Except that this is that's going too far. Device Wi-Fi. So here would be a good time to pivot to so now we're talking develop Phoenix web application. Right, so if we do the summary here, We got a video for an introduction. We've got the environment setup videos. We got a Blinky to test, effectively to test your environment and your development loop. Integrate analog inputs of the soil moisture sensor. That's good. Integrate temperature and humidity probe, I2C. For funsies, we can integrate the display. For fun, integrate LCD via I2C. And then we can develop the Phoenix web application. That's going to be its own thing. And then we've got device Wi-Fi, and then battery, and I have to remember to buy some components. I didn't buy them before because I was going on vacation. I wouldn't be around to pick up the packages, but I should buy them. I should buy them now. I'll make a note of that. My little notebook. I have to purchase God, I don't remember what they're called. Probe resistor. Oops. I forgot what they're called. It's gonna be in my web browsing history. That's fine. At least I think it will be. In fact, it's already in my cart. A current sense resistor, that's what I'm looking for. Yeah. Yeah, the problem I'm running into, and somebody, if anyone's watching this who knows what the hell's going on, if I get like a super sensitive current measuring device, the issue that I think I'm running into is that if it's really sensitive, then it'll just get blown out for like the momentary spikes in current that happen at the beginning of like launching a Wi-Fi application. Right? So I want to measure like the steady state low current of the device, but in a way that like it'll still run without like saturating the capacity of this measuring device. Right? Because I think that's what happens with those the little like needle galvanometer things. Like those have a limited range, and as soon as you hit that range, they don't really let more current through than the max displacement of that thing, I think. Right? So this thing spikes to like 2 milliamps or whatever, but I'm trying to measure several microamps. It's just gonna get blown out, and I'm not gonna be able to measure a thing. So I'm not sure what to do about that. Maybe I'll reach out to somebody who knows what they're doing in this regard. I think they solved this problem with like a switch. So like you started off with like a high range, and then you assume that after that it's just going to be at like a low steady state. Then you flip the switch to put it back into like a more sensitive mode. But I don't remember. I don't remember exactly. I can play around with that. Yeah, I remember. I'll make a note of that. I'll make a note of that. Reach out. In the meantime, I do have that stuff is in my Amazon cart, so I can just put the order in. Okay. So, develop Phoenix web application, does a lot of work there. And then here, optional, and then optimizations. Whoops, when did caps lock come on? Optimizations for power go here. So, introduction. We'll do outline. Content outline. And I suppose I can start doing like a script. So YouTube scripts. Let's see. I actually have I've been using org roam a little bit, so damn it. CF. Oh. Org roam insert. Node find is what it is. Node. Oh, I thought I had it. There we go. So YouTube scripts. Embedded YouTube. Come on, scripts. So the first one is the introduction video. Introduction video. We need a title. And basically just copy this. Does that copy everything? Yeah, that's not what I want. Okay. So introduction. We'll do environment setup. Whoa, Blinky. Okay, Blinky, integrate analog inputs, integrates moisture sensor, analog inputs, GPIO output, temperature, humidity probe. And okay. Conclusion. So here's what you do. You do this, and you do org roam insert introduction video, and then we need a title for the video. So intro, developing a embedded system. Whoops. If I can spell embedded right, that would help my credibility. Intro, developing embedded system ESP32 or something. I don't know. I don't know how to use pipes. So the intro's that. We can... What the heck? There we go. Developing an embedded system. Intro, developing an embedded system. So, what would I say? I would say welcome, or I'll say hello. Today we are developing, this series of videos will walk you through the process of developing an embedded system. We will develop a Compost Monitor that includes some light circuit design and integrates via Wi-Fi with a web component. Wi-Fi with a web. Not web component, that's like a technical term. With a web service. We'll say that. And then kind of setting audience expectations. We're going to say, like, the videos are targeted at people who know how to program, but not necessarily in C or C++. I'm guessing we're going to get a lot of web devs. A lot of, like, more than 5 people will ever look at this. Not necessarily C or C++, but, like, if you have experience programming like Python or whatever, you're curious about embedded stuff, this might be a good video series for you. If you want to follow along, you'll need the following components. 1, a breadboard. 2, an LED. 3, what else? You need a collection of resistors. Specifically though, so to do, specifically you'll need an LED with some with some specific characteristics, some specific specs, specifically of some specific values. I'll have to look into that, because you also have to be able to buy these things. Like, I don't want to make people buy one of these, like, huge kits when they're only going to need 3 resistors. So, there's that. Okay, breadboard, LED, resistors. You'll need an ESP. You need the ESP32S3 dev kit. And then you'll need jumper wires. Provide Amazon links, because so There are links to all of these things in the description, as well as on the project website, which I'll need to do is create a project website, as well as on the project website, in the video description, as well as on the project website, who do create project websites. To do create project website. No affiliate links. Okay. I'm providing this all for free deliberately. I'm not making any money. No affiliate links. I'm not making money on this. Just like the videos. Subscribe to my channel. And follow me on Twitch and other social medias. Just please like the videos, subscribe to my channel, follow me on Twitch and other social medias. Cool. Okay, you'll need jumper wires to connect stuff on the breadboard. I guess let me just start pulling in some Amazon links then. Okay, so ESP32 S3. Here is it's the dev kit C. Development kit. This is I'm using dev kit. What is it called? Dev kit C. 32 S3 dev kit C. And here's a link to, let me see. Does this work? So if I open a private page. Okay, so there's that link. You only need one, so let me do that. Okay, because the one that I purchased before, I believe does not let you buy not a 3. Okay, so it's a little bit more. Right. So I bought mine at $17.88. This is the one I purchased. So it's $17.88, but you got to get 3. So per unit, it's less, but you have 3 now. But this one, you can buy one for $10. So I think they're the same. I think they're the same specs. You might even actually be able to use some of the LEDs on here, but I don't know. In any case, I'll put this link in here. There's that. Okay. I guess while I'm in private mode, so I'm okay with this. Let's see. What else? You need. I just had this. Where is it? A breadboard. So any breadboard will do. But this one comes with some jumper wires. Like, that's big. You don't need that many posts or anything. In fact, you don't even need like a full size one, but these ones that come with the jumpers are probably going to be the best. Because you don't need 4 of these. You just need... That's the thing. You don't need 4 of these. You just need 1. You need this. But, like, this is $8.75. And this is $6 and you get more. This is $10 and you get all the things. So, maybe I'll do this. I don't know. Okay, a breadboard. 2 jumper wires. Any will do. Here's a link to one that comes with jumper wires. Any breadboard will do. And then I'll put this one in here. Let's see. Got it. So if I bust out, so this one. Wait, does it come with? No, it only comes with these. Not with these. One assumes, and no LEDs. So why is it showing them? I don't know. Okay. Jumper wires. So there's that. Jumper wires. Any will do. Jumper wires. Any will do. So here's those $5, $4. The problem is these are only one type. These you got multiple types. Right, the little ends. Yeah. Any will do. Here's a link to more than you'll need. You need an LED. Let's see. What? So LED. No. Single LED. How do I get a single LED? Under computers? No. Electronics. No. Not really electronics. Is there like a tools? Maybe tools? Industrial and scientific. That might be more what we're looking for. Here we go. Not exactly. What are these? That's cool. I don't need to spend $13 on it. Okay, so here's the thing. I want you to not have to think about which LEDs and resistor values you need. Oh, man. And, like, I don't want to, like, sell a kit either. Like, that would be a pain in the butt. You don't need 500 LEDs. Like, I don't know how to buy just one red LED. Red LED. Here we go. 100 of them. That's better. Better than 500. LED. Single LED lamp. Single LED. 100 pieces. Yeah, like that's too many. That's too many. Yeah. 10 pieces pre-wired. That might help. Let's see, what do you got? These are pre-wired. Okay, that... I guess that's the problem I'm having. Is... No. I don't want you to have to buy, like, a whole lot. If you're just trying to follow along here. 100 is not as bad. Okay, what do we got? We got some specs here. Forward voltage on the red one, 2 to 2.2 volts. I think that's what I have set up for mine. On this thing. No, they're 1.8 to 2.2 on these. Why are there so many different ones? When all the different ones are the same. Maybe this is just the container? Because they're all 3 millimeters, but all the ones of the same color have the same ranges. Typos notwithstanding. Right, this one says 30 millimeters, but it's 3 millimeters. They're identical. Yeah, I don't know what to have you do. If you're just trying to follow along, I guess this is better than 100 of a single color, maybe, or is there? Let's see, RGB LED. If I need to buy another thing anyway, I guess I could just plan to do a single RGB LED. But again, I don't want you to have to buy 100 of these things. $10 is... I guess I can... Yeah, I'm struggling with this decision. I guess because I'm gonna teach you, then you don't necessarily... I don't necessarily need to get all of exactly only the components you need. But I mean, that's the best way to follow along, is to just not be able to make a mistake. Because you could, if you make a mistake, you could burn out like at least a pin. Yeah. I guess because I'm teaching you, but that's still the thing. I don't want you to have like 100 of these things just lying around. So I don't think there's really a way to go. Well, how's this? Is this just a broken out? It's got the resistors built in. Ooh. Is there... Oh, no solder was new. What? First one didn't work, but otherwise, yeah, so this looks like iffy. Yeah, I don't want to have to help people debug bad solder. Yeah, those look like maybe they're done by hand, even though they're surface mount components. Okay. Yeah. Look at that. That does not look good. Wait. Yeah. What? Yeah, I gotta say, their example does not look nice. So this one looks cleaned up. I think that's what it's supposed to look like. Except the cathode is over there. Yeah, I don't know. I'm gonna make you buy this. Terrible idea. Okay. Can I, and is it just this? Yeah. Unfortunately, they don't really come in packs of less than 100. Let's do... Maybe I'll do both. What is this? Is any of these RGB? No. Because I was thinking, like, if there's a set that comes with some RGBs and some others. What's this? Copper foil? What is it? Copper foil tape. What is this? And then diffused LED kit. I'm sorry, what? What's in the kit? Okay, just for 20 bucks you get all of these and all of these. No thanks. All right. Here we go. 50 for $6. That's a little better. So maybe do this. RGB LEDs. But I don't know if I want to get into that. It'd be fun to do it. I think that's like a for fun RGB LED. So here's an LED. So I'll do RGB LEDs there. And then for fun. And you want a red LED. 3mm red LED. Do they come in less than 100 pieces? No. They don't. Can we sort by price? Low to high. Here we go. Red, 50 cents. That's more like what I'm looking for. But it costs $9 anyway. Right, this shipping is insane. $9.90 delivery. Man, remember when Amazon used to be good? Okay, like, if you're buying 100, because that's all you can get. Like, I'm looking for maybe like a 50, like a 10 at a reasonable price. 30? 10 would be good. But like, why are these even listed if I can't buy it? Ugh. Man. Alright, welcome to the future. Yeah, it looks like they just come in packs of 100. Unfortunately, that seems to be the reality. Red and green. 2-color. I don't need an ultra bright. Back of 10 for 1041, yeah. Yeah, okay. Back to featured. Bestsellers? No, featured. Just it's the first result. $6. They're obviously red. 5mm or 3mm? Does it matter? They're the same price. Forward voltage is the same current. So the slightly bigger one will be easier to see. Or, you know, to pick up the handle. So we'll do that. Transparent slow flash. What? What was that? Transparent purple. Transparent red. Weird. Okay, so that's it. 100 pack. In case you needed 100, you do not. 100 pack of red LEDs. 2.2. So we'll get to forward voltage 2 to 2.2. 2.0 to 2.2 volts. Current 20 milliamps. Just literally the first link on Amazon. Okay. For fun, RGB LEDs. And that's like that would be a more advanced, like you got to figure out resistors yourself. So you need resistors. Oh, for a forward voltage of 2 to 2.2 volts at 20 milliamps. I think I had done this math before. Do I have a pencil? No. I think I took it with me on vacation and didn't bring it back. Okay. Well, not to my desk anyway. I think it's in my bag. So, I mean, you only need 3 resistors. What do we have here? This one is a 6. It's impossible for you to see this. If I make myself big, I don't think you can see the colors that it is. How about I got my this cloth that I use to clean my glasses. Okay. Can you see the colors? It doesn't focus. You got... Yeah, that washes it out. I can barely make out these colors. I believe it's blue. And then brown. Or gray. I think it's gray. Blue. Gray. Black. And then gold. So 680. 1/10 of that, 68. And then the final bar is also gold? Or is it brown? I think it's brown. There's a plus or minus 1%. I think it's brown. I don't know how anyone can possibly tell. Hey. Come on. Focus. Well, let me do left to right. Be like this for you. Blue, gray, black. You can see the black in the middle. And then gold and brown. I think that's right, because these are labeled as plus minus 1% quarter watt resistors. So 68 ohms. So you need one 68 ohm resistor. And I don't remember the other two. I guess you might as well get, let's see, resistors. $17 values. What are the 17 values? You don't get 68K or a 68 ohm, which is nice. If this is to be believed. $50 pieces of 100. Okay. $25 pieces seldom used resistors. Perfect pin. Number 24. Perfect for breadboard. Well, if I was thinking of letting you have a 68, then I cannot recommend this kit.
I'm not sure about that, but I have to have it taken. The new call is
So maybe then this one. 0 ohm to pack of 525. If you pay a little bit more, you get a ton. That's so many. What? That's cool. Comes a little case. These are half watt. They're kind of big boys. Like way bigger than we need. Do you get like a 68? Let's see. There's a 68K. 68 ohms. 20 pieces. I mean, this might be the coolest one. Half watt. They're like thicker. Yeah, this says 50 values, but is that right? Yeah. $50 values. 25 of each except for 100 ohm, 220 ohms, 1 kilo ohm, and 10 kilo ohms, which have 50. Allegedly. So yeah, maybe, I don't know, maybe I'll just recommend one of these kits with not 17 value, the 50 values. I think this is what I have, actually. Yeah, this looks like what I have. So maybe I'll just recommend this. This is what I have. You only need 3 resistors. But it's next to impossible to buy just 3 resistors at a reasonable price. Here's a kit. for 1,300 resistors. Which includes the 3 you need. Specifically, you need 168 ohm ohm 168 ohm. I guess I can just measure the ones I have. So this resistor is 32.6 ohms. What are the markings? Let's see. So we got orange and orange. That should be 3 and 3, right? 330, and then I think that's red. Three 330 times 100. 33000 33K. Yeah. So 133K ohm and 1 of this other value. Purple, green, black. Purple is 6 or 7? 7. So 750. And then brown again. $7.5K. It looks like. Right? Because 750 times 10 is 7.5K. I think that's right. We'll measure it. Yep. Yep. And then 7.5K ohm. Really, that's all you need for those. 3 resistors, unless if you're not using the RGB LED. Yeah, even then. So right now this is not much of a script, but we're getting there. So hello. This series of videos will walk you through the process of developing an embedded system. We will develop a Compost Monitor that includes some light circuit design and integrates via Wi-Fi with a web service. The target audience for these videos are people who already know how to program, but do not necessarily have any experience with circuits or low-level languages like C or C++. So I might need to refine my approach to code as a result of that. Because I'm kind of... I think I've written all this C++ for this, which might not be the best way to do it. Yeah. I guess I'll wave my hands at a lot of that stuff. Which is fine. If you want to follow along, you'll need the following components. A breadboard. Any breadboard will do. Any breadboard will do. I'll do link to one that comes with jumper wires. Is there. Jumper wires. Any will do. Yeah, male. Any will do as long as you've got an assortment of male to male and male to female. Link to more than you'll need is here. You'll need one LED. Unfortunately, one LED. Unfortunately, these do not seem... Unfortunately, it's nearly... Unfortunately, it is cost prohibitive to obtain just one or two. Just one or two. You'll probably end up buying a big pack. Before you buy, you can buy whichever ones I will be teaching you enough for you to make almost any of the hobbyist LEDs work. But if you want to buy it all beforehand, just make sure all they work, but if you want to purchase it all at once, just check that the forward voltage is 2.2 to 2.2, and the current I is 20 milliamps. I'll have to rephrase that. I guess we're writing the script now, so I'll rephrase it now. So you need an LED. An LED. Unfortunately, buying just one is expensive. Just one is expensive. So unfortunately, just one is expensive. You'll want, if you're just following along, you'll want LEDs with a forward voltage, often shown as VF, of 2.0 to 2.2 volts, with a current of 20 milliamps. And actually, 68K is not correct, I think, for 2 to 2.2 volts. The forward current, I sub F, of 20 milliamps. Let's see. Let me refresh my forward voltage knowledge here. LED driver is an electrical circuit used to power a light-emitting diode. Must provide sufficient current to light the LED at the required brightness, but must limit the current to prevent damaging the LED. The voltage drop across a lit LED is approximately constant over a wide range of operating current. Therefore, a small increase in applied voltage greatly increases current. Oh. Datasheets may specify this drop as a forward voltage at a particular operating current. Very simple circuits are used for low power indicator LEDs. More complex current source circuits are required when driving high power LEDs for illumination to achieve correct current regulation. Simplest is through a series resistor, commonly used for indicators and digital displays in many consumer appliances. The circuit is not energy efficient because energy is dissipated in the resistor as heat. The LED's forward voltage depends on its material. Ohm's law and Kirchhoff's current circuit laws are used to calculate the appropriate resistor value by subtracting the LED's forward voltage from the supply voltage and dividing by the desired operating current. If the supply voltage is close or equal to the LED's forward voltage, then no reasonable value for a resistor can be calculated, so some other method of current limiting is used. Uh-huh. Uh-huh. Series resistors are a simple way to stabilize the LED current, but energy is wasted in the resistor. Miniature indicator LEDs are normally driven from low voltage DC via a current limiting resistor. Currents of 2 milliamps, 10 milliamps, and 20 milliamps are common. Sub-milliamp indicators may be made by driving ultra-bright LEDs at very low current. Efficiency tends to reduce at low currents, but indicators running on 100 milliamp or microamps are still practical. Okay, in coin cell powered keyring type LEDs, the resistance of the cell itself is usually the only current limiting device. Uh-huh. LED intensity, yada yada. The value for the series resistance may be obtained from Ohm's law, considering that the supply voltage is offset by the diode's forward voltage, which varies little over the range of useful currents. What is V switch? The voltage drop across the switch in volts. Oh, this is for when you're using a circuit element as a switch, as opposed to just a mechanical switch. MOSFET drivers, blah, blah, blah. Okay. So we can say 0 for the switch. We don't have an actual switch. So 3.3 volts. 3.3 volts minus forward voltage, which is 2.0 to 2.2 volts from this pack of LEDs. Right, the ones that I used are actually a lower minimum VF. 1.8 to 2.2. That could have been a disaster. Okay. So we'll calculate it twice. Once at 2.0. Once at 2.2. And get a range. So VF equals 2.0. So 3.3 minus 2.0. And then we're saying there's no switch, so 0 there. Divided by the operating current, 20 milliamps. The maximum continuous on current is shown. Many circuits operate LEDs at less than the specified maximum current to save power. Oh, you can go less, yeah, to save power. And then you round up, yeah. So I think you don't need... The way LEDs work, you just need enough potential across to make light. But once it starts going, once it's able to go, it doesn't matter how many, like, electrons you're sending across, as long as there's a potential. I think. Right, so you can have a tiny current, and it'll produce light, but it's a tiny amount of current. But it's at the right voltage. If that makes sense. But yeah, I mean, 20 milliamps is a lot. But I think it can sink that. But you got 1.3 volts over 20 milliamps equals the desired resistance. So 1.3 divided by 20e minus 3, 65. Round up to 68 ohms. Right, so if I plug in 68 back in, well, that's assuming a forward voltage of 2.0. But if you hit it at a 2.2, which is the maximum, 3.3 minus 2.2 over 20 milliamps, that's 1.1 volts over 20 milliamps. So that's 1.1 55. But then if we plug it back in, into this rearranged version, LED, this other one here, let's see, where'd it go? There. V power, 3.3, minus forward voltage, 2.0 or whatever. We'll say it's 2.0. And then divide by, if we pick 68, which is the higher, rounded up to a normal value, then that is 3.3 minus 2.0, which is 1.3. 1.3 divided by 68. That is 0.019 amps. 0.019 amps is 19.1 milliamps. So actually, we can probably set that resistor value way higher. And then it'll be whatever forward voltage it wants to be. But it'll just be way dimmer. But I don't know. It doesn't really solve the problem of not having to buy 1,000 resistors just for one or two. Alas, that is the world we live in. Okay. Yeah, so I think this is it. You know, you need a collection of resistors. Unfortunately, like the LEDs, it's hard to purchase just the ones you need. But because components vary if you keep doing electronics projects, you'll probably be able to use at least. So you'll probably want to have different resistor values on hand. Let's see. Here's a pack. Here's a pack with lots of options, reasonably priced. I don't think I need to mention that. Here, I purchased a 3-pack, but you need that. You'll need jumper wires to connect stuff on the breadboard that's already up there. So 1, 2, 3, 4. Whoops. 4. This is a 5. 4, 6. Already have that. So you'll need. You want the SHT, temperature, humidity. Which one do I have? Thought I had an SHT like 35 or something like that. SHT 30? This is the one I have. But unfortunately, these ends are not breadboard compatible. See them? They're like ridged. Which is good for ruffles, bad for when you want to breadboard something. Are these different? 5 pieces. I don't need 5 of them. It's also $20. Huh. SHT 31. Yeah, it'd be cool to have one of these with like breadboard compatible ends, but and then if you have to solder it yourself, that's a real pain in the butt. Oy. Let's see. Which is the one that I purchased? Let's see. SHT 31 or 35? Which one do I have? I gotta look at my account history. Hang on. Hang on. What? Go away. SHT. Here we go. So this is the one I bought. I don't remember what price. Presumably for what it says there, it might have been less. 1493 at the time. But unfortunately, the ends do not fit into a... The ends do not fit into a breadboard. And I don't think they make various other versions of this. So FS304. Let's see. FS304. Yeah, these aren't breadboardable. None of these are. I mean, they're all presumably coming from the same place. Let's see. Soil sensor. Soil sensor. This is what I want. This is what I want, but with different ends. And I don't want to also have to make people buy those clips. Just to get it on a breadboard, you know what I mean? Irrigation kit. Not quite what I'm looking for either. What? How does this work? What is this? Now I'm curious. Is it like you... Is it like a dipstick? Like you put it in and then you pull it out and then see? Yeah, it's like a dipstick. I guess it's smart, but why is it $13? It's like... It's just like a soil dipstick. It's the same technology for testing if your cake is done. Might as well use a toothpick. That's funny. This one, like, I guess I don't want to have to make people solder either. And then, because, like, these little breakouts also tend to be, like, look at this. Like, you could have picked any of the lot as the picture here. But you pick one with, like, some of the worst looking solder. That you, like, what are you doing? If you're trying to fool, like, you're trying to fool people, the reviews will come in. Eventually. Although, because there's, like, so many of these. Like, look at this. They're all the same. They're in the same color boards, too. But, like, yeah, $20, though? Like, that's so much. Like, this at least seems to have... Is there anything on the back? Yeah, it's like the same thing. It's the same thing. These are surface mount components that look like they've done by hand. Like, what is this? What is this bubbling going on here? What is that? What are you doing? Yeah, like this looks like it was done with through hole solder. Like look at like there's like a short circuit right there. I don't know if it's meant to the both of those are ground, but like come on. None of these have reviews. Let's see. Sort by bestsellers. Here we go. We got some reviews. One review. These high let go ones seem to be pretty reliable. Or at least they sell decent components. Where's the 1-star review? Show it to me. No, I don't want to sign in. I want to look at it. Do I have to be signed in to see the reviews? See more reviews. It's making me sign in. I don't want to do that. Nah. I'm already logged in over here. Yeah. I'm looking at the reviews. I'm signed in on this, but this is a different component. This is a BME 280 atmospheric pressure sensor. I'm more interested in these line mark? Yeah, SHT temperature humidity probe. I mean, it looks like if you want it, you gotta get it at $20. And you gotta get the clips. So I mean, here it is. Yeah, I do have this other one. This one that comes in a little box. But it's not... Right, it has an adapter. It's a pack of 3. This guy. The same one, I think. Hello. So it's got this little end, which is annoying to work with, but it does come with 2 others. But it does come with these little breakouts. So you can just clip it in like this. And now you can shove a... Right, so this clips into this breakout, which should be hard to mess up even if you're doing surface mount without the right process. Then you just plug in your little... Yeah, you can plug in the jumpers into there. Ooh. I just grabbed a bonded pair here. Easy peasy. But I believe this is just temperature. No moisture. But I think this video demonstrates that it's waterproof. That's why there's a little vase full of water. So they're doing exactly what I did. Plug it in, show you with some jumpers. And then that Arduino is presumably set up to do, or is it an Arduino? It looks like an Arduino. And there it is. And look, it's waterproof. It is very hot wherever they are. 30 degrees. Indoors, presumably. Dang. Cool. I don't know what I'm looking at, Mr. Zach. But yeah. So, but it's just temperature. So I suppose... Yeah. I think I do want to use this. Just the fact that you can't breadboard this is the limiting factor, really. Otherwise, it'd be perfect. I'm looking at this as if you could see it. The that other probe. Yeah, just the fact that you can't breadboard this means I can't possibly recommend it. Okay, temp and humidity sensor. Temperature, humidity, probe. Quite often you can put like Arduino into this. With DuPont wires. Here's a temperature, but no... I think no humidity. Search DS18B20. One-wire digital thermometer. Interesting. Not an I2C interface. Huh. Okay, but not quite what I want then. What are all these resistors for? Ground data and VCC. Parasitic my foot. Pressure, temperature, and humidity. I mean, this is... not great. Well, these are probably going to be what I want. It doesn't need to be super accurate. And it comes with wires, like, who cares? Also looks like they're the wrong kind of wires. If the wires in the picture are the ones they send you, they're useless. Right, because Arduinos have holes on them. Wait. Well, which one are you selling me? A 3 or a 4 pin? A 3 pin. DHT11. No. Here we go. Humidity and temperature sensor. Where does it like to live? Because it can get pretty warm and damp in the compost bin. Let's see. Attentions. Attention to chemical materials. Yeah. So if it gets screwed up, I don't put it in the oven. Where am I going to find 50 to 60 Celsius and humidity less than 10%? It's strongly advised to keep the humidity and temperature sensors working under the same temperature. Mounted as far as possible from parts that may generate heat. Yeah, connection wires. Sure. Welding temperature should be below 260 Celsius. Avoid using the sensor in a dew condition. Store it at 1040 degrees C. This is a translated data sheet. Okay. Let's look at this again. Yeah, it does say it's one wire. Bring it back, bring it back. How does it communicate? Maximum 90% relative humidity. Pull up 5K. Two pins of data? What? Single wire, two-way. Single bus data format is used for communication and synchronization. That's interesting. There's a checksum. Yeah. Wait, so how does this work? Complete data transmission 40-bit, and the sensor sends higher data bit first. 8-bit integral RH data, 8-bit decimal RH data, 8-bit integral T data, 8-bit decimal T data, 8-bit checksum. If the data transmission is right, the checksum should be the last 8-bit of 8-bit integral RH data plus 8-bit decimal RH data plus so just add them all together and take the last 8 bits, and that's a checksum. Okay. I guess that works. So, wait. Okay, so pull down, start signal, then let it pull up and watch for a response. Then it should be low to acknowledge, then back up. Interesting. I've never implemented a one-wire protocol like this. That would be interesting to do. But I don't think I'm gonna. Well, that's not what I want to teach, though. Here's one. Temperature and humidity sensor module. But you have to solder yourself. Unfortunate. Yeah, all these reviews are like, they're not being tested. uses a 6K pull-up. Is that true? Yeah. It's missing a component. Big blobs, too. Like, this is my kind of solder job that I'm really bad at. Yeah, so maybe high let go, not particularly reliable then. I feel like I've bought stuff from them before. Maybe just individual components. And not like a unit like this. Yeah, I'm not sure what to do then because, again, you can't breadboard that. Although, SHT20. Here's this one. And no soldering required. Yeah, maybe this is what I gotta do. Okay, so I gotta buy stuff. Let's see. High let go SHT20. Hello. This one. Yeah, this one. I guess I'll add it to my cart. Yeah, because I don't know. I was stuck between doing like in just informative kind of thing versus a follow along kind of thing. And now I'm really leaning into the follow along kind of thing. So in order to do that, you got to be able to buy the stuff. And I don't want you to have to buy other things in order to get specific things that I have to work when I could just buy a thing that works. So those things I just added to my cart here. High let go SHT20 temperature humidity sensor, these things, right? Like why not have you buy this instead of making you buy the probe and then also the these clip things that I've been using. Splicing wire connectors. Right, like these. Like these are great and I'm really happy I bought them personally. But I don't want you to have to buy these just to get something working. Right. And I don't know if these are really recommended for like in your house, but they work great for small electronics projects. Okay, so there's that. And I'll do the link to this as well. Yeah. You need the temperature and humidity sensor module, SHT20. Here's a link to a 2-pack that doesn't require soldering. Whoops. Nope. Is it here? There it is. Is that the right one? B082F7GDQS. Yeah, that's the right one. 2-pack that doesn't require soldering. You can use your big brain to find ones you can solder yourself. Okay, so if you want to follow along, you'll need the following components. A breadboard, any breadboard will do. Here's a link to one that comes with jumper wires. Jumper wires, any will do as long as you've got a sort of male to male to male to female. Link to many more than you'll need. Here's a link to many more than you'll need. You'll need an LED. An LED. Unfortunately, it's hard to buy just one. If you just want to follow along, here's a link to a 100-pack of LEDs I know will work. But I will be teaching you everything you need to know to make any LED work in a future video. Make most LEDs work in a future video. Actually, in the next video. In the Blinky video. The video, you can watch that if you want. Should be able to purchase any LED. Should be able to use any LEDs to use pretty much any LEDs, as long as you also have a few resistors. Three A. And just for fun, if you're interested in integrating in the optional RGB LED portion, here are some RGB LEDs to buy. Okay, and actually I should also add, I don't have any RGB LEDs, so I'm gonna add these to my cart. All right. Big Amazon order. It's a business expense, even though this makes no money. Okay. What do I have? I've got those LEDs, the temperature and humidity sensors, some current sense resistors, and then I also needed new oscilloscope probes. Okay, so all in my cart. Cool. What else? Unfortunately, like LEDs, it's hard to purchase just the ones you need, but because components vary, if you keep doing electronic projects, you'll probably want to have... But if you keep doing electronics projects in the future, you'll appreciate having a variety of resistor values on hand. Here's a pack with lots of options at a reasonable, I only ever use a reasonable price, even if you only use a couple. Even if you only end up using a couple. I'm not going to say what values you need here. Okay, you need the ESP32S3 development kit. Here's a link. Here's a link to one. I personally purchased a 3-pack. These things can come in handy. I'm not going to say that. Here's a link to one. You need the temperature and humidity sensor module. I'll be using the SHT20. Here's a link to a 2-pack that doesn't require soldering. If you don't mind soldering, buy them for less. SHT20. So $9.49 versus... Actually, not really much cheaper. Yeah, any one of those should do. Here's a link to a 2-pack. It doesn't require soldering. Oh, but you might actually need to solder if... Yeah, okay. ESP32S. ESP32S3. Let me look over here. ESP32S3. Pre-soldered. Yeah, okay. Let me do that. Yep. Okay, I'm using... Here's a link to one that is pre-soldered. Okay. Okay. You need that, and then capacitive soil moisture sensor. Like these? It's got too much stuff. I don't want that. I just want this. Here we go. Unfortunately, they don't sell them in 1-packs. Whoa. What the hell is this? Plus, I made it waterproof. Okay. Liquid electrical tape. Wait, what is this? With different... I mean, this is basically what I have. I have a different version, quote unquote. Capacitive soil moisture sensor. I have this one. There. So, and they're saying liquid electrical tape? Liquid electrical tape. Actual goop. Nice. There's a lot of brands for this. Is it just black silicone? Yeah. For the most part, I think it is. They all seem to be priced around the same. 9 schmeckles for this. How big is it though? 4 ounces versus some of these other ones, 4.2 ounces. Does it come with like a brush, or am I on my own in that regard? This one specifically that I'm looking at here seems to have an applicator brush cap. So if I'm actually shoving this in my 2-pack for twice the price, yeah, just about. I don't need 2-pack. So, tiny 1-ounce tube. Might be worth it, depending on the price. Nope, it's the same price as the big thing. So, it looks like we're going with the 4-ounce can. I got a text. Yeah. Okay. So that's cool. That'll be used. I'll use it on this. So I'm going to use a link to this. So here's a link. And you need a soil moisture sensor. Spencer, here's the one I'm using. But there's a newer 2.0 version of the same type of device. It won't make too much of a difference. Again, this one requires no soldering, which is good. And then I did say male to male, male to female. There's almost no reason for you to have female jumpers, because yeah, I mean, breadboard, yeah, it's fine. That assortment should have all of them, so that's okay. Alright, so those are the ones. Here's the one I'm using. For some reason, these also don't seem to come in packs of 1 or 2. I don't know why anyone would need 10. Alas. Recommended depth. Yeah, down there. Okay. So there's that. Is that everything? Okay, and then if... And then optional. If you're... Optionally, if you want to run the device off of a battery, you'll need a power supply. Power supply. DC power supply. DC power supply. You don't need these super expensive industrial things. Adjustable power supply. They all look fancy now, but this is all you really need. Unfortunately, this one's, I mean, $30 when you buy. Why buy that one when you buy one of these? You know, these fancy ones for just a little bit more. DC variable power supply. And I want to find one that's cheap. Why are they so expensive? Oh, these look scary. All right, we're already at like $15. All right, so maybe. Yeah, I mean, this looks scary. I don't remember where I bought mine. It must have been on Amazon, because that's back then I was buying everything on Amazon. Let's see. I'm looking at my orders here again. Search supply. Oh no. Everything counts as supply. Power supply. Yeah, because like everything from markers to pencils to everything. Hey. Apparently I did buy a fancy power supply. Okay, here we go. Alright, back in 2016, I purchased this, which you can no longer get. Probably because it might be dangerous. If I was gonna guess. Thing is intermittent noise levels. Not a good paperweight. Alright. The problem is nothing. So when I bought it, what did I buy it? What did I buy it at? I bought it for $30. So at $30, this is the closest thing you can buy. But then you also need the banana jacks. Oi, oi, oi. Yeah. I mean, for $30, you might as well pay $40 and get one of these. You know what I mean? All right, so the shopping list, let me see. The shopping list is getting kind of long. So if you follow my links, this one will run you $9.99 USD. Dollars. All right. If you buy all these jumper wires too, that's $4.99. $4.99. Okay. 100 pack of LEDs. This one is $5.99. $5.99. Whoops. And then the RGB LEDs are also $5.99. $5.99. Oops. No. There we go. $5.99. Resistors, again. This is $12.99. $12.99. Okay. Here's a pre-soldered kit. $10, I think. $9.99. $9.99. Temperature and humidity probe. Another $10. $9.49. $9.49. And these moisture sensors. $9.99. Yeah. And then if you want to run the device off a battery, you'll need a few extra components. Then you need these, you need regulators. Regulator. Buck. these. The e-boot mini guys. You'll need buck converters. Link. Come on, copy and paste. Is that the right one? BO1MQ, yeah. Buck converters. That'll run you $12.55. And then you'll also need like the 9-volt battery clips. So here's the ones I bought. There might be cheaper ones. Is there others? With alligator clips? Yeah, no. So here. So 9-volt battery clips. Save that. Those will run you, what, $6? $5. $4.99. Come on. Oh my gosh, I can't type. All right. $4.99. Really, I think that's it, but you also probably want nine other tools you might want. One, wire strippers. A variable power supply. And what's this? What's this? On-time wildlife feeders. A universal digital. A feeder timer. Yeah, I'm unclear what it does. You know, I don't know what it is, but it's universal and digital. Okay, buck converters, 9-volt battery, plus 9-volt batteries. And if you don't already have one, you'll want a multimeter. What's a good one? We'll just go on here. Multimeter. Doesn't have to be expensive. Doesn't have to be fancy. I mean, the problem is this is a limited time deal. So they're all about the same price. So this is fine. What's the difference? Blue versus black. All right, I don't care. Get this one. Here we go. If you don't have one, you want a multimeter. Doesn't matter which. Here's one. Yeah, like as long as it's got, they all have the same stuff, so it doesn't matter. And then I think that's it. Components wise, it's a lot of stuff, but other tools you might want, especially if you're going to be using those other 1,000 resistors. Tools you might want, especially if you're going to be making more electronics projects. Wire strippers. I personally prefer I like these like really basic ones that are not even like you can adjust them, but like by setting this the screw here. Right? Like these have a screw. You can shift the screw along on this thing to like get different wire gauges. So like this stops it here. So if you adjust it, I don't even have a screw. So if you adjust it, right? So now it stops it earlier and the gap is bigger. It's hard to see. But you can adjust the size of the gap by adjusting the screw. I don't even do that. I just like set it, as you could see. I just set it to like some really big value and then just kind of go by feel. But that kind of thing takes practice. But okay, so if you're more spools of let's see, spool wire. You want something like the 18. I think 18 is. What are these? This is about the right gauge for breadboarding. This solid core wire. It doesn't say what gauge it is. 22, I think. Yeah, these are 22 solid core. Whereas these are like really thin strands. These are what gauge is this? I think this is like 30 something. Or just 30? 30 or 33? 18 is very thick, I think. So you want 22. Spool wire 22. Yeah. 22 solid core. Wires. Yeah, because like spool wire 30, Then you start getting into really thin. These are really thin. When they're really thin, they're useful for connecting stuff where you got to keep it out of the way and like tape it. I don't know. I used it for something. Don't remember exactly what. Yeah, I don't remember what I needed it for. Why a solid wire wouldn't work. Mostly just because you can get more wire also. But yeah, so some spools of solid core wire, wire strippers, cutters, variable power supply, other tools you might want if you're, especially if you're turning into a hobbyist and using some more of those 1,000 plus using more of those 1,000 plus resistors, spools of solid core wire, wire strippers, variable power supply, banana plugs, and those are banana plug. Banana plug cables. Oh, leads. There we go. There's these, and then the mini grabber ones. Mini hooks, sorry. Mini grabber, I believe, is trademarked. These are the... I like these the best. This random brand. They're not the cheapest price, but they have like all this stuff, and it's pretty good quality. A learn to solder kit, nice. A flashing European siren. Anyway, yeah. Banana plug leads, mini grabber, mini clip, mini grabber leads, etc. Oh, and a soldering station. Plus solder and soldering station. Okay. Okay, so if you want to follow, you'll need a bunch of components. I'll provide links to everything in the video description and also on the materials page of the project website. These aren't affiliate links or anything like that. Feel free to buy them wherever you want, and you should also feel free to purchase alternatives if you think they'll work for you. I shouldn't do that. I shouldn't say that. I shouldn't confuse the issue there. You can buy them wherever you want, wherever you can find them. I'm not making any money on this. I'm not making any money on this. Just like, subscribe, follow me on Twitch, etc. Follow me on Twitch, all that. You will need a breadboard. Any breadboard will do. I'll link to that. So, cost-wise, I'm asking people to invest how much? I know Emacs has a calculator, but I don't know how to use it. $9.99, $4.99, $5.99, another $5.99, $12.99, $9.99, $9.49, plus $9.99. I think that's it. So this is like $100 project. Well, really, the project itself is like, if you divide this by 100, right? It's 5 cents plus, and you assume you just have jumper wires. So 5 cents there, 1 cent for the resistor, or we'll say 5 cents for the resistors, plus the actual ESP32. Then the temperature and humidity module, that one you need to buy, and the soil sensors. Right? If you think of like breadboard, jumper wire, LEDs, and resistors as like pantry items that you're buying, then the rest is just that. Plus then if you've got the converters and the clips for the battery piece of it, $47. Where the big costs are these 3 things. Well, on these, plus the converters. Whoa, what happened? Wait, what happened? Oh, CNI introduction video. Orgrome visit. I want to find this. There we go. All right, so if I was filming this video, what would it look like? Hello, this is a series of videos that is going to walk you through the process of developing an embedded system. We will develop a Compost Monitor that includes some light circuit design and integrates via Wi-Fi to a web service. The target audience for these videos is anyone who already knows how to program, but not necessarily with any expertise in low-level systems or languages like C or C++. If you want to follow along with the project, you'll need a bunch of components. That probably should not do that at this point. I feel like right now would be the time to dive into the actual project itself. So we'll say the bill of materials for this project. Project, if you're starting from scratch, is probably around $100, which is a lot. Which is a lot for a lot of people. But the main components for the project come in around closer to 50. Stuff like resistors and whatnot. Resistors and LEDs, you'll have to buy in bulk just to use one. It's probably around $100. Yeah, I know that's a lot. I know that's a lot for... I know that can be a lot. Alas, it's hard to walk down to the local Radio Shack. Alas, gone are the days of walking to your local Radio Shack and purchasing a single resistor for a few cents. So the project has an embedded system component, an embedded system that serves as the probe. Well, okay. Hi, this is a series of videos that is going to walk you through the process of developing an embedded system. We're going to develop a Compost Monitor that includes some light circuit design and integrates via Wi-Fi with a web service. I'm going to go through the basics of integrating. I'm going to go through the basics for how to integrate. How do I put this? Like, it's basically a whirlwind tour of the kind of thing you need to do for an embedded system. Go through the basics for... I'm going to give you a whirlwind tour of the kinds of things you need to do to integrate components in an embedded system. So GPIOs. Target audience for these videos are people who already know how to program, but do not necessarily have any experience with circuits or low-level languages like C or C++. I don't like lyrics in my groovy music, especially when I'm trying to think with words. Target audience for these videos is anyone who already knows how to program, but does not necessarily have any experience with circuits or low languages like C or C++. I will teach you. I will teach you how to manipulate general purpose input and output pins. Output pins. I'll teach you a little bit about analog to digital converters. You'll learn a couple of basic embedded system serial communications protocols. And you'll learn about how do I express this? The like power stuff. And you'll learn a bit about how embedded systems can run off of a battery for years. Yeah? Okay. Hi. This is a series of videos that will walk you through the process of developing an embedded system. We will develop a Compost Monitor that includes some light circuit design and integrates via Wi-Fi to a web service. I'm going to give you a whirlwind tour of the kinds of things you need to do to integrate components in an embedded system. The target audience for these videos is anyone who already knows how to program, but does not necessarily have any experience with circuits or low-level languages like C or C++. I will teach you how to manipulate general-purpose input-output pins. I'll teach you a little bit about analog to digital converters. You will learn a couple of basic embedded system serial communications protocols, and you'll learn a bit about how embedded systems can run off of batteries, can run on batteries, can run off of a battery for years. The bill of materials for this project, if you're starting from scratch, is around $100. I know that can be a lot. Alas, gone are the days of walking to your local Radio Shack and purchasing a single resistor for a few cents. Yeah. Yeah, I don't think I can make it any cheaper, not really. Not without making you solder stuff, I think. Which is one of the other prohibitive elements, right? Like if you can't afford to buy the pre-soldered sensors, then you're going to have a hard time affording the soldering iron and solder station to do stuff. That sucks. But that's the way it is. And it's unfortunate. All right. I'll think on that. There must be a way to like, maybe I can do some kind of software sim somehow. But we'll see. We'll see. Hello. Series videos, blah blah. I'll teach you how to manipulate. I'll teach you a little bit about analog to digital converters. You'll learn a couple of basic embedded system serial communications protocols, and you'll learn, or else you will learn a bit about how embedded systems can run off of a battery for years. The bill of materials for the project, if you're starting from scratch, is about $100. If you follow along, you'll need a bunch of components. I'll provide links to all of these things in the video description, and also on the materials page of the project website. These are not affiliate links or anything like that. Feel free to buy them wherever you can find them. I'm not making any money on this. Just like and subscribe, follow me on Twitch, all that. You will need a breadboard. Any breadboard will do. You'll need jumper wires. Again, any of them will do. You just need an assortment of male-to-male and male-to-female type jumper wires. You'll need an LED. Again, unfortunately, it's hard to buy just one. If you just want to follow along, here's a link to a 100 pack of LEDs that I know will work. I'm going to be teaching you everything you need to know to be able to make most LEDs work in the Blinky video, which is the next video in the series. So you should be able to use pretty much any LEDs you might have on hand, as long as you also have a few resistors. Speaking of which, you need a collection of resistors. Unfortunately, like the LEDs, it's hard to purchase just the ones you need. But if you're going to keep doing electronics projects in the future, you will appreciate having a variety of resistor values on hand. So I've linked to a pack of over 1,000 resistors at a reasonable price, which is fine even if you only end up using a couple. Here's where we start to get into like actual components for the project instead of just like, I call them like pantry items. You need the ESP32S3 development kit. I'm using the Dev Kit C. There's a link below to one that is already pre-soldered. If you want to do a solder it yourself project, feel free to do that. It's fun to do, good practice. You will also need a temperature and humidity sensor module. I will be showing off the SHT-20, which does not require any soldering. But you can use, if you understand what I'm teaching you, you should be able to use any other component that you can integrate. But we'll get there. You'll need a soil moisture sensor. Here's the one I'm using. There's a link below to the one I'm using. There's a newer 2.0 version of the same device. But again, it's not going to make too much of a difference. Unfortunately, these also don't seem to come in packs of just one. For some reason, you need to buy 5 or 10 of them. Even though I don't know. I have some ideas, but I'm not going to say them. Optionally, if you're going to want to actually run the device off a battery, you're going to need a couple of extra components. These will be useful for any project where you're going to run it off a battery. So you need the buck converters so that you can convert 9 volts down to what the microcontroller's circuitry actually needs. And you'll need a clip for the battery to clip onto the 9 volt, supply the 9 volts to something else. Some links for that available below. If you don't already have one, you're going to want to have a multimeter. It does not matter which one. Cheap is fine. There's a link to one random one below. Just search multimeter. Literally first link on Amazon that was the cheapest. That works. They're all the same. Other tools that you're gonna might want, especially if you're gonna turn into a hobbyist and be doing more of this stuff, you'll want spools of the 22 American wire gauge, 22 AWG solid core wire. These are kind of solid wires. They're compatible with breadboards usually. which is good. If you buy those, then you're going to want wire strippers and cutters. Usually you can use the same tool for both of those functions. You also probably want a variable power supply. So one where you can set some values on the supply and have it provide that many volts. Then you probably also want the banana plug leads, mini grabber leads, and combinations banana plug mini grabbers, so that you can connect onto your power supplies and clip onto wires on your breadboard. And you might also want a soldering station, but now we're getting more advanced. Or if you're buying kind of the cheaper version of some of these components, and you want to put them together yourself, it's always fun to do soldering projects on your own. At least I think it's always fun. Your mileage may vary. So all of that rings in at way more than that. You're looking at $40 for a power supply for a pretty cheap one. Probably $20 for the leads. Probably $15 to $20 for the solid core wire. You can get wire strippers for $5. Soldering stations, another $40. So all told, you're probably going to spending up to $250 for everything here, which is kind of a lot. But yeah, there's no but. It is kind of a lot, unfortunately. Yeah, it is what it is. If you're like me, you will have like a lot of this stuff just lying around. Like you just have spools of this. You just have like these are things that are just like pantry items. I just have resistors. I have a bunch of capacitors. I have like you just kind of accumulate those kinds of things as you work on projects. For someone just starting out, obviously you don't have that, so it can be a bit of an investment. But really what you need is just the components, breadboard, jumper wires, and then, resistors, LEDs. You can get away with this stuff is optional. You don't need to actually run your thing off a battery. I'll show you how it is so that when you decide to do it, if you decide to do it, then you can buy these things. You don't need to buy the power supply. You can just run it from your computer's power supply, which means you don't need the solid core wire. You don't need the wire strippers. No power supply needed. No soldering required if you buy all the components that don't require soldering. And yeah, hopefully they all work. Some of these components, the quality is kind of sketchy. So we'll see. Yeah, okay. And then I'm not sure how to transition into the bill of materials. I'm going to teach you this, and this. So this will be a section, bill of materials. So here's an intro. So first, the embedded system, the Compost probe. We'll say the Compost probe, the web service, architecture overview, super high level architecture. We'll say that. Super high level design. We'll say that. This is the part where, so what am I going to be showing you? Here you'll see a diagram. So for the beginning of this, you're going to see me. I'll just say hello, blah, 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 blah. target audience, yada yada. I'm going to teach you this, 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 and this. High-level design. So, high-level design, I'll show you a diagram showing showing the compost bin. I don't know why it's capitalized. Compost bin. Showing the compost bin, the compost probe. Showing the compost bin outside my house. The compost probe in the bin. The Wi-Fi connection into the house. And the Wi-Fi connection between my computer and the Wi-Fi network. And the Wi-Fi connection between my computer and the access point. So I'll do that like this. Okay. So, and then as I speak, so as I show that, I will speak saying there's a diagram. So a compost probe. Well, I'll introduce the project first. So we'll say, I'm terrible at keeping my compost bin happy. It gets too warm. It gets too cold. It gets too damp. It gets too dry. I can never seem to Goldilocks it for long. To that end, I need a diagnostic tool to help me see when it's getting to anything without having to actually check the bin. My plan is to, and then transition to the diagram, zoomed in on the compost bin. Plan is to put a probe in the compost bin that collects temperature, humidity, and soil moisture from the bin, or from the compost. That put a probe in the compost bin that collects temperature, humidity, and soil moisture, and then sends that over Wi-Fi to a web server. Yeah? Over Wi-Fi to a web server. And so this will zoom probe in the compost bin. Yeah, and then I'll zoom in on the various components on the diagram. Or somehow I'll need to figure out the animations for that. Something will be animated, it'll be on the screen, my face will not be, it'll just be a voiceover. And then I can start talking about the compost probe. The probe itself, maybe I should show it as a final product. The probe itself, show final product. Here. the probe itself, and I need to figure out my notation for myself on these. The probe itself consists of a temperature humidity sensor integrated via I2C. We'll talk about what that is. We'll talk about what that is a little later. And a capacitive moisture sensor integrated with an analog to digital converter. Talk about that later too. Okay, consists of a temperature humidity sensor integrated via I2C. We'll talk about what that is a little later, and a capacitive moisture sensor integrated with an analog to digital converter. We'll talk about that later too. The probe itself, let's see. Show final product. The probe itself consists of a temperature and humidity sensor integrated via I2C, and a capacitive moisture sensor integrated with an analog to digital converter. We'll talk about that later too. The microcontroller powering the probe is a ESP32S3 development kit that has built-in Wi-Fi capabilities. The microcontroller powering the probe is an ESP32S3 development kit that has built-in Wi-Fi capabilities. Every, we'll say 15 minutes, 10 minutes, I don't know. Every 15 minutes, the probe will collect data from the environment. The probe will collect data from the environment and push it out and send it to the web server running on my local network. On the local network. Okay. Probe itself consists of a temperature and humidity sensor integrated via I2C. There will be animations or something. I don't know how I'm going to do it. It'll be bad, but it'll be fine. Microcontroller powering the probe is an ESP32S3 development kit that has built-in Wi-Fi capabilities. Every 15 minutes, the probe will collect data from the environment and send it to the web server running on the local network. The web service. If you're coming from a web development background, feel free to let me know. Feel free to implement this. However you want. I will be showing off how to do it. How to do this with Phoenix. With the Phoenix web framework. I'll disclaim this. So I'm not a web developer. Pretty much in any sense. but I do my best. I will be showing off how to build a web service to collect and display the Compost Probe data using the Phoenix Web Framework. Right, so how does that feel? How does that feel to say? So, the Compost Probe. The probe itself consists of a temperature and humidity sensor integrated via I2C. We'll talk about what that is a little later. And a capacitive moisture sensor integrated with an analog to digital converter. We'll also talk about that later. We'll talk about that later too. Yeah, either way. The microcontroller powering the probe is an ESP32S3 development kit that has built-in Wi-Fi capabilities. Every 15 minutes, that probe will collect data from the environment and send it to the web server running on the local network. I'm not a web developer, pretty much in any sense, but I do my best. I will be showing off how to build a web service to collect and display the Compost Probe's data using the Phoenix Web Framework. Data is the probe connects to an API endpoint that uploads a reading, which consists of the temperature, humidity, etc. Uploads a single reading, which consists of the temperature, humidity, etc. Uploads a single reading into the database. A web front end displays this data. A web front end accessible via a web browser displays this data in a fancy graph. Eventually, perhaps capable of sending alerts? No, I won't even. Don't even commit. Don't even try to commit to more project. But it would be cool for it to send alerts or something like that. Send me an email, send me a text. Be like, hey, your compost bin is annoying. When did this text come in? I don't know. All right. Web front end, accessible via web browser, displays this data in a fancy graph. And I'll be showing that. Okay? Fancy graph. If you want to follow along and purchase all the components you need, the bill of materials for this project, if you're starting from scratch, is around $100. I know that can be a lot. Alas, gone are the days of walking to your local Radio Shack and purchasing a single resistor for a few cents. If you want to follow along, you need a bunch of components. Don't need that paragraph. If you want to follow along, purchase all the components, you'll need the bill of materials. Project is around $100 if you're starting from scratch. I know that can be a lot. Alas, gone are the days of walking to your local Radio Shack. I will provide links to all the things in the video description and also on the materials page of the project website, which is to do. I need to make a website for the project. These aren't affiliate links or anything like that. Feel free to buy them wherever you can find them. I am not making any money on this. Just like, subscribe, follow me on Twitch, all of that. You will need a breadboard, jumper wires. You will also need an LED. Unfortunately, it's hard to buy just one. A collection of resistors. Again, like LEDs, it's hard to purchase just the ones you need. You will need the ESP32S3 development kit. You need the temperature and humidity sensor module. And you'll need a soil moisture sensor. Really is the 3 components. Optionally, if you want to run the device off a battery, you'll need a few extra components. And if you don't already have one, you'll need a multimeter. Does not matter which. Here's one. Okay. I might have to revise this. I'll have to rebuild the project and do it, but that's good. Okay. Bill of materials complete. All right. Thanks for conclusion. Thank you for your interest. Thank you for your interest. If you're ready to get started, go ahead and jump to the getting started video for your operating system. If you're ready to get started, go ahead and jump to the getting started video for your operating system. Or if you just want to watch the normal development, I don't know what to say here. If you just want to watch the normal development, you can head straight into the Blinky video. Done. Okay. So there are going to be 3 environment setup videos. Environment setup GNU/Linux. Environment setup Mac OS. Environment setup Windows 11. Ew. So I have to make those. I gotta make a Blinky video. So that's the one I'll do next. So what is this? CNI. That is. And I think I have to stop now. It's after 6. And I gotta start cooking dinner. And feed the cat. He's probably ravenous. The poor boy. He was sick. But yeah. Thanks for watching. This is boring as hell, but I'm doing it. And I figure since I'm doing it, I'll subject you to watching me do it. Nobody cares. It's fine. Nobody's watching. Doesn't matter. There is a little bit more development I have to do, which might be a little bit more interesting, but it's just debugging the power consumption of the whole thing. So yeah, like I said, I'm just getting back from vacation, so I didn't even have my laptop. I had to pull it out of my bag and plug it in and move stuff around. My overhead cam's not even plugged in or on. So yeah, here I am. Everything's a mess from, it's just how I left it. I'm trying to figure out like, oh, what am I going to take? These dice, those dice, whatever. yeah. So I'll clean everything up. I got some more stuff to do. I got some stuff to purchase. Hopefully it'll be here by the next video, but probably not next week for sure. Tuesday, I think, depending on how the delivery stuff works out. Then yeah, I can do more of the low power stuff. In the meantime, I'm gonna be writing more of these scripts, and then I think once I have a rough idea of how they're all gonna go overall, then I'm gonna start recording them. I don't think I'm gonna do, like, I've seen a few Twitch streamers / YouTubers who like record the videos on stream. I don't like that. That seems kind of cringe to me. Because there's like no production value. It's just talking head. And like showing something on screen. So like, I don't like that. I want to do like animations, slides, like showing illustrations of what I'm actually talking about. Whatever. Like, more production value. In any case, thank you for watching. I know this is boring. So if you are watching, that's amazing. Let me know what you'd like to see. Like, I did a little bit of, the last time I was on, I did a little bit of Shenzhen IO, even though I was like muted almost the whole time I was playing the game, which is annoying. But Shenzhen IO would recommend. It's like pretty much kind of what it's like to do embedded systems development. There's less of a like an explicit puzzle element to it all. But yeah, so thanks for watching. I'm gonna sign off now. Peace.